Determine each of the following antiderivatives. So for part A, we have the integral of 2x subtract 3 all divided by x subtract 2, and we're going to integrate that with respect to x. So at the moment, this is a fairly complex function to be dealing with. So what we're going to do is we're actually going to use a method of division to try and simplify this fraction. So I'm going to use synthetic division for this problem. So for synthetic division, I'm going to use the x subtract 2 that's in the denominator and solve that equal to 0, and we'll get x equals 2. So that's the number I'm just going to put here. And then the numbers along the top of this setup is going to be the coefficients on the top line. So 2x has a coefficient of 2 and minus 3 is the constant term. So now that I've set up the synthetic division, we start by adding down the first column, and that will just give us 2 here. And then we take this number and we multiply it by this 2, and that will generate the number that goes in this position here. So 2 times 2 gives 4. And then once again we add down our column, so minus 3 plus 4 will give positive 1, so that will sit in that position. And that is now a remainder for this division. So what this tells us is that the original integral is going to be equivalent to, and as this was 2x to the power of 1 originally, this is just 2x to the power of 0 is the new term we get after division has occurred, and anything to the power of 0 is simply 1, so that's just going to be 2. So we have 2 plus the remainder of 1 divided by the divisor, which was x subtract 2. And we're going to integrate that with respect to x. So just to make that clear, that this integral here is equivalent to the integral that we were asked to calculate originally. So now this is something we can fairly easily integrate. So the integral of 2 simply becomes 2x. So when we have a constant and we integrate it with respect to x, we simply get 2x back in this case. And then we add on to that, and 1 divided by x subtract 2 has the derivative of the bottom line, which is 1 on the top line. So that tells us that this is going to be a log. So we have log e of x subtract 2, and then we have plus c, which is the constant of integration. So that is the answer to part A of this example. For part B, we have the integral of 4x subtract 3 divided by 1 subtract 2x. And again, we can use a method of division to simplify down that fraction. So this time I'll show you how to use long division with a question like this, although you could use synthetic division if you wanted. So we're going to set it up. So we're dividing 4x subtract 3 with 1 subtract 2x, which I'm just going to write as minus 2x plus 1. So that's the same thing there. And then we need to think about what would you multiply negative 2x by to get to positive 4x. And the answer is negative 2. Now we take this negative 2 and we multiply it by the negative 2x, and that will give us 4x. And then we also take the negative 2 and we multiply it by the positive 1, which will be negative 2. And now we're going to subtract away those terms from the 4x subtract 3. So when we do that, we have 4x subtract 4x, and that will give 0x, which is what should happen. If that doesn't happen, you've made a mistake up earlier. And then we'll also have negative 3 subtract negative 2, which is negative 3 plus 2, which gives negative 1. So for this question, the negative 1 is the remainder. So now that we've done that, this tells us that the original integral can now be written as the integral of negative 2. So that's this negative 2 that was on top of our long division setup. So we have negative 2. And for this one, I'm just going to split up the integrals. So we're going to have negative 2 dx plus, and then we have the integral of negative 1, the remainder, over 1 subtract 2x. And that is with respect to x. Now, if we look at that fraction, it almost looks like the derivative of the bottom line, which is negative 2 is on the top line, but it's not quite. So what we're going to do is we're going to multiply the top line by 2, so we're going to have negative 2 on the top line. And because you're not just allowed to multiply your integral by a number, as it would change it, we also have to divide by 2 as well, or multiplying by a half is another way that you could think about that. So now perhaps you can see why I chose to set this up as two different integrals, so that we could do that little process to make the derivative of the bottom line of the fraction appear on the top line. So we're now up to the stage where we could get our answer. So this is going to be the integral of -2 is going to be -2x, and then we add on to that a half times log e of 1 subtract 2x plus c. So that second integral we had in the line above, the half times the integral of -2 over 1 subtract 2x, the integral becomes log e of 1 subtract 2x in brackets, and this half out the front is multiplying that log term in our answer. So that is the answer to part B of this example.